Lesson number 19 is on value word problems and geometry theorem angle, which the author says really means angle. So we'll take a look at that. Let's start off with just doing a word problem here. You've got, so I can zoom in on this just a little bit. You've got this person who has 50 nickels and dimes, right? 50 nickels and dimes, right? So it could be, they might have 45 nickels and 5 dimes or any combination thereof, right? And all the value together was $4, okay? And you want to be able to solve to find out how many nickels and how many dimes, right? So I'm going to say that n is equal to my nickels, the number of nickels, and the letter D is going to be, you guessed it, for dimes, right? So we're going to have to write two equations so that we can use substitution or elimination to solve this. So a couple of facts. First one would be what? Or a couple of equations. N plus D has to equal 50 coins. All right, so that's one equation. And the other equation is going to have to do with the money, right? So we know that a nickel is worth 0.05 cents, right? We're talking dollars, right? And then a dime is 0.10. So the equation with money says that the value has to equal 4. So we have 0.05 n plus 0.1 d for dimes has to equal $4. All right. So we need to figure out a way to eliminate one of these variables, right? And remember, you're in charge of this problem here. So let me show you what happens if I rewrite the nickels and dimes problem and say, you know, let's do this, and they say that it's worth 5 cents. So instead of saying 0.05, we can say that a nickel is worth 5 cents and a dime is worth 10 cents. And instead of $4, $4 is also the same thing as 400 cents, right? So in this case, I could use this to maybe get rid of those decimals. Not necessary, but I'm going to do it. So what I want to do is take this first equation and multiply it by the number 5 so that I get 5n plus 5d equals, don't forget you got to distribute to all three terms. So 50 times 5 would be 250. Now I'm going to take this equation and I'm going to slide it right underneath the white equation. That's the money equation. And all I got to do is subtract these two equations from each other. 5 minus 5 would be 0n. 10 take away 5 is 5d. 400 take away 250 would be what? 150. 150. Okay. So now to solve for the letter D, all I have to do is divide by 5. And when I divide 150 by 5, I'm going to get D, the number of dimes, is equal to 30, right? So if I have 30 dimes, that means that I can go back to this first equation, n plus d equals 50, and just substitute in. N plus 30 equals 50, right? So to solve for the nickels, all I have to do is subtract 30, and I'm going to get what? 20. So the number of nickels is equal to 20, and the number of dimes is 30. All right. Let's take a look at the next problem. A fishmonger sold codfish for 6 pence each All right, so we'll use C for cod, I guess, and mussels for 1 pence. If Harriet bought a total of 26 items, so what do we say? This is going to be C for cod, so we have letter C plus M is equal to 26 pieces of seafood. And then it costs 6 pence for, so the second equation, we'll do that in white. We have 6 pence. Let's see if we can move this up just a little bit. We have 6 pence for cod, so it's 6C, and 1 pence for mussels, and it costs a total of, excuse me, 86 pence. All right. Well, you notice something. Uh, mussels are already in coefficient of 1 here and a coefficient of 1 here, right? So I'm just going to slide that red equation underneath C plus M equals 26. And then all I got to do is subtract 6 minus C is 5C. 6 minus 1 is 5. The M cancels out or is eliminated, and then this would be what? 0. 8 minus 2 is 6. Divide by 5, and C would equal 12. So that means I bought 12 cod fish, and let's see, altogether I bought 26 items, right? So if I bought 26 items, cod plus mussels equals 26, and I have 12 cod, and the mussels is going to have to equal that number. So I'm going to subtract 12, and it looks like I got what? 14 mussels. Okay, that's on page 94. Then the next thing they talk about is this angle theorem, where if you have an angle, if you have two triangles, and if the two angles are equal to each other, then the third angle is also equal, right? It's a triangle. And if they're similar triangles, meaning they have the same shape because they have the same angles, they not necessarily have to have the same size, right? It could be proportionally scaled. They could be scaled, right? One could be smaller than the other, but have the same similar angle structure. So let's look at this example, 19.3. And just want you to just remember that this angle has the two little slash marks through it, and this angle over here has the two slash marks. So those two angles are equal to each other. And then this guy has one slash mark, and this guy has one slash mark, right? So this, we could imply that if two angles are equal on two separate triangles, then the third has to be equal also, right? So I can do this one in pink. That means this guy right here is in pink also, right? Okay. So now all we have to do is, and it kind of helps to have colors actually sometimes. All I got to do is look at, let's say this 5, okay? 5 is in between the red angle and the blue angle, right? The red and the blue. And the red has double hash marks and the blue has a single, right? So what is between the blue and the red over here? What letter is between those two? Well, that would be X, right? So let me put an equal sign here. So if I'm setting up a proportion, X and 5 are proportional to each other, right? Okay. And now let's take a look at the number 6, but let's use a different color. Let's use blue for that, okay? All right. Blue is in between the red and the pink angle, right? So I'm going to go ahead and write that over here. Notice how X and 6 are in the same triangle, so I'm going to put them in the same fraction. And then what's between the red and the pink angle over here? The red and the pink would be the number 4, right? So let me go ahead and write that. All right. So now I can find what the value of x is, right? By doing the cross product, right? So I'm just going to do 5 times 6 is equal to 30. And 4 times x, I get 4x, right? And then to get rid of the 4, we divide it out, right? And 7 times 4 is 28, with 2 left over, right? And 2 over 4 will be a half, right? So 7.5 is the x, 7.5. And what would the other side be? Let's see. I think the book left this as a fraction, improper fraction. Or so that would be what, 15 over 2 is what equals to x. Either way, right? Same answer. Or 7.5. Now we got to find y, right? Let's find y. Well, we already know that 4 and 6 are the same, right? And we got to find what y is. So y is right here. And y is resting between the blue and the pink angle. So the blue and pink angle over here would be the number 7. Number 7, okay? So let's cross multiply again. You get what? 7 times 6 is 42. And then y times 4 is 4y. Divide by 4. And you would get, I can divide this by 2. Divide this by 2, right? And that would be 21 over 2. Or, if you like, we could call this, what, 10.5. Okay. Hopefully that doesn't bring back too many bad memories of geometry. But the key here is to just realize that the relationship that 5 and x have with each other, right? And it's because they're nestled in between the same angles, right? The red, and I call this one the blue, right? And this one is the red and the blue one as well. So, and 6 over here, this guy 6 is between the red and the pink angle, and the red and the pink was 4, right? So, you know, these two angles have a relationship. All right. Anyway, hopefully that this all makes a lot of sense. And let's see what's over here. We can set up practice C, so we can get one more practice on this one. Find x and y. Okay, so let's see if we can identify x's partner on the other side, right? So x, excuse me, x is in between the single hash mark, and then this guy right here is going to be the 3 hash marks, right? And this one will be the 3 hash marks, because angle, angle really means angle, angle. It really means that all 3 angles are the same, right? Okay, so if I'm in between the 1 and the 3, there's the 1 and there's the 3 right there, the 3 hash marks. That means x and 5 are cousins, right? X and 5. And then if I go over here and look at y is in between the 1 and the 2. In between the 1 and the 2 would be the number 4 right here, right? So this is 4, right? So they're cousins with each other. And that means that, look at this in the blue, the 3 is between the 2 marks and the 3 marks. Over here, the 2 marks and the 3 marks would be here and here. So 3 is partnered up with 5, right? So 3 is partnered up with 5. So in other words, I'm going to use these to build my fraction, right? So let's say that we want to solve for y first, okay? Or x, I'm sorry. So if I put x on top, I'm going to put an equal sign to separate the two triangles. x equals 5. Now, I don't want to use the y because that's just going to give me another variable that I can't solve right now. But if I use the blue, the 3 and the 5, I just have to remember the 3. I really should have wrote these the other way, right? I really should have wrote the 5 first. Okay, everybody see why? The 5 is, this 5 right here is on the triangle that has the x and the y, right? So I got the x first here and the y first here, so I'm going to put the 5 first here. So the 5 goes over here, and his partner is 3. So now we can do what? We could just cross multiply, right? So we have 5 times 5 is 25. And then when I cross multiply this guy, I get 3 times x. So you could just divide that out and get 8, 8 and 1/3. So do the same thing to set up for y, and go ahead and try solving that one. And then let's go ahead and work the problem sets. Let's go ahead and get the multiples of 5 again on that, and we'll see how that works out for us. And we'll see you in class.